Hey, this is James, and this is the circuit building project for audio electronics. And what we're doing is taking this speaker and throwing capacitors and resistors in the circuit in parallel and series and seeing what it does to the audio signal. So I'll start by hooking up the complete circuit without anything changing the audio signal at all. So we'll just have the basic audio signal. Come here. And then we'll hear the audio. And now we'll throw a single 100 ohm resistor in the circuit, which will make the total resistance in the circuit 108 ohms because the speaker itself has 8 ohms of resistance. And they're just additive because they're in series. So 100 plus 8 is 108 ohms of resistance. Math. And then we'll listen to it now. And the only thing different now is that the volume is reduced because there's less current flowing through the circuit because of the resistance. So the amplitude is decreased. So now we'll throw another resistor, 100 ohms, in series with the circuit, which will make the total resistance 208 because we're adding another 100 ohms of resistance. And we'll listen now and see how different it is. And again, it's just slightly quieter than before because there's even less current because there's more resistance. And now we'll take these two resistors and put them in parallel circuit instead of in series. And that will greatly change the amount of resistance in the circuit. And instead of being additive, the total resistance will be 1 over the resistance equals 1 over 100 plus 1 over 100 plus 1 over 8, which makes it like 6 or something ohms of resistance. Something like that. It's like 6.8 or so. 800 over 116. And now we'll listen to the audio again and see how it's different. Now it's louder again because there's less resistance because now they're in parallel. So since there's less resistance, there's more current and more amplitude of the audio. So now we'll get rid of all this and hook up a variable resistor to the circuit and see how that does things. So now we just have the single variable resistor in the circuit, and we will change how much resistance is in it by turning the resistor, and we'll see how that affects it. The right decreases resistance because it makes it, and then turning it makes more resistance, and then it's so much that there's not enough amplitude, not enough current to even hear the audio at all. So and Cameron, it locked. Make it better.
I'm gonna practice piano and then practice room. Practice music.
Okay. So sorry. And now I'm gonna hook up capacitors to the circuit and see how that affects the audio. We'll be using 10 microfarad capacitors. And so yeah, right now I'll just connect one 10 microfarad capacitor. So there's just that, yeah, just that, and we'll see how that affects the sound. There is significantly less bass in the overall frequency of the song. So you could look at it as a high pass filter or just a low cut on the track now because of the capacitor. So now we're going to hook up another 10 microfarad capacitor and see how that changes it. Since they're in series, they're additive, so now there's 20 microfarads of capacitance. And see how that affects the sound. And now there's even less bass. So all it did was just make more of a low cut or a more drastic high pass filter. And now we'll put these capacitors in parallel with each other and see how that changes it. And just like putting the resistors in parallel, this actually will reduce the amount of capacitance in the circuit. So let me get this off the So yeah, now it's in parallel circuit, and we'll see how it sounds. So now, instead of it being a low cut, there is a high cut on it, or a low pass filter. So yeah, that's how the capacitors work when they're in parallel circuit. So yeah, that's it. Cool.